All right, we're on to our last topic, electricity. This is my most favorite topic in the world when it comes to physics. Okay, here's how the premise of electricity. The premise of electricity is all based on these little guys called electrons. Electrons. I'm going to write them all as little e's with a negative sign above them. Okay, electrons have a special relationship with other electrons. They hate each other. Oh, and with a passion. They hate each other so much, if they even get close to one another, they want to go the opposite direction as fast as possible. Okay? They exert a force on one another. This electron here is going to say to this one, hey, go away. And that one will comply. This electron will go away. The same goes for the other way. This electron will say to that electron, go away. And it will. Okay? There is a force between those electrons. There's a force going on there, pushing them away. Because electrons are pretty much everywhere in the universe, we give a special name to the force that two electrons feel on each other. We call that force the Coulomb force. For you guys in this class, we don't need to remember the special name for this force. What you need to remember is that electrons repel each other. Okay? They don't like each other. They want to go the opposite directions. However, there's this other particle that is pretty much just as abundant as an electron called a proton. I will denote protons as a P+, as right here. But protons attract electrons. Okay? This is the force that holds everything together. So there's always electrons repelling each other. They don't like each other. And protons attract electrons. So that's what holds everything together. Because of this, we get a lot of cool phenomena. When there's not enough protons in an area, okay, we get static charge. We get a buildup of negative charge, okay, or lots of electrons. They want to get away from each other as fast as we can. Thus, we see a static shock. The electrons want to get out away from each other as much as they can, so they jump to the nearest escape route that they can. And a lot of times, this is your nice neighborly doorknob, or maybe it's your nice neighborly ICP student, freshman. You're just shocking them and they're like, ow, that hurts. Well, that's because the electrons are jumping from you to them. Or sometimes it's the opposite. They jump from your friend to you. And you can feel that charge going on. Back to our force, because we have these electrons want to fight each other, if we create a loop, the electrons will continue to travel in this loop. This continuation of motion is called an electrical circuit. For an electrical circuit to work, we need one, a closed loop, and then a source of electrons, or a source of a push to move those electrons along. A general source for those pushing of electrons along is a power source or a battery. A lot of times it's a battery, or it's like plug it into the wall. When we look at electrical circuits, there are three major components that are related to the measurement of those circuits, and so we can quantify what's going on. Those three things are voltage, current, and resistance. Voltage is like the push that we feel. Okay? It's the force kicking the electrons out of the power source, pushing them along. Current is the amount of electrons per second, or time interval. Okay? If you were to think about people moving about in like maybe a house, a push might be a fire pushing them out. They want to run away, get away from it as quickly as they can. Current would be the how quickly they can move out of the building. Okay, so it would be number of people outside per second. The last thing we have is resistance. Resistance is the fighting against the flow. It's the fight against the flow. It's how much stuff, or how hard is it to get out. So an example, like if let's say we had a fire in a house, again, voltage represents the fire, okay? You'll hear me use this analogy a lot of a house in a fire. a fire, the size of that fire is going to determine how quickly you want to get out. If it's just a little candle, who cares? But if it's a blazing inferno, you want to run as quickly as you can. That's going to be your push to get you out. Current is how quickly can you get out. And resistance is like the door that you have to get through. If the door is locked with a deadbolt, it's much harder to get through than a door that is unlocked. Okay? That's going to represent a stronger or higher resistance. We also need to talk about how are those different measurements related when it comes to mathematics, and how are they interrelated. We have a nice formula and a nice law that relates those together. Before we can do that, we need to assign variables to each one of these. So voltage, we're going to give a capital V. Okay, a capital V. Capital V for voltage. For current, we're going to give it an I. Okay, don't ask me why. We're just going to call current I, okay? Current is I. You see I, you think current. And finally, resistance, we're going to give a capital R. Okay, now we have those three variables, we can write down Ohm's law. Ohm's law looks something like this. It's going to look like V equals I R, where current times resistance will give us our voltage. Okay, this is a very easy formula to use, just like our speed of the wave formula. So if I give you, let's say, if I give you voltage and current, we can solve for resistance. Suppose I give you the voltage and the current. Let's say we've got 12 volts and we have 3 amps. We can solve for resistance. All I would need to do is divide by my current on this side and on this side, and that would give R by itself. So the new equation would look like this. We'd have voltage over current is equal to resistance. And if I do that arithmetic, I'm going to see that 12 divided by 3 is going to give me 4. And the unit on resistance is the ohms, or ohms, capital Omega. Okay? Ohms, okay? That's capital Omega. The unit on current is the ampere or amps, and the unit on volts is voltage, okay? So those are our three units. If you see volts, think voltage. If you see amps, think current. If you see ohms or capital Omega like that, think resistance. To finish up our topic on circuits, we need to think about the types of circuits. And there are two major types of circuits: series and parallel. Whenever you see series, think in a row. In a row. Okay? So a circuit diagram might look something like this, where if I got, that's my battery, I've got a resistor, and it comes down, there's another resistor, and we have a third resistor. Okay? They're all in a row. Okay? For electrons to pass through, they have to go through this one, and finally through the last one to get back to the voltage source. So it has to go through each one of those individually. For parallel, think choices. If I draw my circuit again, so I've got a battery here. Okay, I've got my battery. I'm going to have choices. So it's like this. I've got one resistor here, and then I've got another resistor here, and finally maybe a third one hiding in here. So an electron has a choice. It's coming around the loop, and it can either take option 1, or option 2, or option 3. Okay? It's got choices. So if you ever see a circuit and you're following along and you see there's choices, think parallel. Okay? If you ever don't have any choices, you have to go through everything, it's in a row, think series. Okay? That concludes our discussion about circuits and electricity. I hope you enjoyed this video. Please give me your comments in class sometime. Other than that, have a great day. Bye-bye.